So how does this happen? How does one person's vision take a company that was famous for, making video games awesome and turn it into the trillion-dollar engine that's powering the entire AI revolution? Well, today we're going to unpack the architectural blueprints of Jensen Huang's ambition. It's this set of core principles, decades in the making, that are literally engineering our future as we speak. Our journey is going to start with a bet so big it almost broke the company. From there, we'll see how that single bet scaled up to completely redefine what a computer even is. And that, in turn, created new laws of intelligence and eventually led to building these incredible factories whose only product is thought itself. So let's dive in. All right, let's start with the moment Nvidia almost died. And I'm not talking about a bad product launch or dip in the market. No. This was a single, strategic choice so incredibly risky that it threatens the company's very existence. It was a bet on the entire future of computing. So what was it? The decision was CUDA, a completely new computing architecture that, at the time, basically no one was asking for. And Jensen's bet was to put it on every single gaming GPU they sold. This wasn't some little side project. It burned through all their profits. Their market cap just plummeted from $8 billion all the way down to $1.5 billion. I mean, from the outside, it looked like total corporate suicide. So what on earth did Jensen see that Wall Street didn't? Okay, so here's the principle behind that insane gamble. Jensen bet against pure technical elegance in favor of just raw distribution. And as you can see here, there's a long history of this playing out. Think about RISC architectures. They were beautifully designed, super efficient chips that, for the most part, failed. Why? Because they were up against x86, the architecture that was inside basically every PC. x86 was kind of complex, a little clunky, but it had this one unbeatable advantage. It was everywhere. And here's the key. Developers don't code for the most elegant platform, they code for the largest audience. And that right there, that's the whole bet in a nutshell. By embedding CUDA into millions upon millions of gaming PCs, Jensen wasn't just selling a feature. He was building a Trojan horse. He was creating a distributed supercomputer that was hiding in plain sight. So when the deep learning revolution kicked off a decade later, researchers didn't have to go out and buy special hardware. The world's most powerful AI development platform was already sitting right there on their desks, and it was paid for by gamers. But of course, that success created a whole new kind of problem. The CUDA platform was so powerful that researchers immediately started pushing it to its absolute limits. The AI models they dreamed of building were just too huge to fit inside one computer or even a dozen computers. The problem literally outgrew the PC. The only solution required a completely radical new way of thinking. Stop thinking about the chip and start thinking about the entire data center as a single, unified computer. And this led to a philosophy Jensen calls extreme co-design. The best way to think about it is like going from designing a high-performance engine to engineering an entire Formula One car. The engine, the chassis, the aerodynamics, the driver, everything has to be optimized together as one single system. And as you can see here, Nvidia had to become experts at everything, from the silicon all the way up to the AI algorithms, and get them all to work in perfect harmony. I mean, just look at this list. It gives you a sense of the absolutely mind-bending complexity we're talking about here. This is not a simple flowchart. It's a dynamic, interconnected system where every single piece, from the networking cables to the cooling systems, affects the final performance. This isn't just chip design anymore. This is systems architecture on like a planetary scale. So if the data center is now one giant computer, what is it actually designed to manufacture? The answer isn't just faster calculations. It's a brand new product entirely, intelligence. And it turns out manufacturing intelligence follows a new set of physical laws. Jensen lays out these 4 stages. First, you've got pre-training. That's where an AI basically reads the entire internet, learning from the vast library of human knowledge. But then it hits a wall. So you move to post-training, where the AI starts generating its own synthetic data. It creates new worlds of information to learn from, breaking its dependency on us. The third stage, test time, is where the real work begins. This is the heavy-duty computation of reasoning and planning. And finally, you get to Agentic AI, where one AI can spawn entire teams of specialized AI agents to work together and solve incredibly complex problems. And this quote reveals a massive strategic insight. See, for a long time, the industry thought that inference, just using a trained AI, would be computationally cheap. Jensen saw it completely differently. He knew that inference isn't just fetching an answer, it's thinking.
And thinking is hard. It's metabolically expensive work for humans and for machines. That insight meant the demand for compute wouldn't just be for training AIs, it would absolutely explode during their everyday use.
So this new kind of computation, this really expensive thinking, it needed a whole new metaphor for what a computer even is. The old ideas just, they didn't fit anymore. And this slide just breaks it down perfectly. For decades, we thought of computers as digital warehouses. Their job was to store stuff you already made, your documents, your photos. They were a line item, a cost center on the IT budget. But now we're in the era of generative computing. These data centers are no longer warehouses. They are factories. They don't just store information, they manufacture intelligence on demand. They're not a cost anymore, they're a revenue-generating engine. And you have to understand, this is not just some little technical shift. It's a fundamental economic one. It changes the entire purpose of computation in our society. The most valuable commodity isn't stored data anymore. It's newly generated intelligence. So how do you make these kinds of decade-long bets? It takes a lot more than just good strategy. It requires a leadership philosophy that doesn't just try to predict the future, but is actually designed to manifest it, to literally engineer a specific vision of reality into existence. This is Jensen's core operating principle right here. He doesn't guess what's next. He reasons from the most fundamental truths, the laws of physics, the speed of light, to figure out what is ultimately possible. And once that path is clear, his entire job becomes shaping the belief system of the industry, of his partners, of everyone, to pull that inevitable future into the present. And his company is structured just like his computing systems. It's a co-designed machine for turning vision into reality. I mean, think about it. Over 60 direct reports, no one-on-one meetings, a culture of solving problems collectively. He makes sure everyone is working on the same system, bought into the same vision, so that when the time comes to make that next giant leap, the entire organization moves as one. So the crucial point is this. When you pull back and look at the whole picture, from that absolutely existential gamble on CUDA, to creating data center scale computers, to the dawn of AI factories, Nvidia's entire journey has just been the relentless execution of a single, powerful, and deeply reasoned vision. And this brings us to a final, pretty profound question. The first industrial revolution that manufactured mechanical power, and it changed human civilization forever. We are now, right now, at the dawn of a new industrial revolution, one that manufactures intelligence. If Jensen's vision is fully realized, what happens to our world when intelligence is no longer this scarce biological resource, but an abundant, engineered commodity?